So how do I identify a right-angled triangle using Pythagoras theorem? Well, if we have a right-angled triangle, then the rule for Pythagoras theorem will be true. So the first thing I'm going to do is identify if these are right-angled triangles, where the hypotenuse would be, or C. Okay, and we should recognize that the hypotenuse, or C, is always the longest side. So for question 1, this would be C. Question 2, this would be C. Question 3, this would be C. Now, it doesn't have to always be the top right length. You could have the triangle in any orientation. So, for example, if it looked like this, then our hypotenuse would be down here because that is the longest side length. So it's important to be aware that our longest side length could be anywhere on our triangle. Now, if they are right-angled, then this relationship of a squared plus b squared equals c squared will be true. Now, you should already have covered that the lengths A and B are both of the shorter lengths in either order. So this could be A and this B. This could be A and this B. It doesn't matter which way around we do them, as long as A and B are the two shorter sides. So if we then write this in using Pythagoras theorem, what is A squared plus B squared? Well, A squared is equal to, in this case, 6 squared, because A is 6. And 6 squared is 36. B squared is 8 squared, which is 8 times 8, which is 64. And C squared is 10 squared, which is 10 times 10, which is 100. Now, if A squared plus B squared is equal to C squared, then we have a right-angled triangle. So let's try that. A squared is 36. B squared was 64. Well, 36 plus 64, that's A squared plus B squared. Well, that is equal to 100. And 100 is, in fact, the same as C squared. Therefore, it is true that A squared plus B squared does equal C squared. Therefore, this is a right-angled triangle where the right angle is opposite our hypotenuse. For the second one then, we have A is 6. If A is 6, then A squared is 6 squared, which is 36. B squared is going to be 2.5 squared. And 2.5 squared, you can do that on the calculators. You get 6.25. And then C squared, well, that's 7 squared, which is 7 times 7, which is 49. So let's test it out. Let's see if it is true. Is A squared plus B squared equal to C squared? Well, A squared plus B squared is going to be 36 plus 6.25. We just calculated them. 36.625. You should be able to see pretty quickly that this is not going to work out, because when you add these together, you get a decimal, 42.25. Now, 42.25, that is not C squared, so that is not equal to C squared. Therefore, this is not a right-angled triangle. If it was a right-angled triangle, our hypotenuse would be 7. You would have to do the square root. Our C squared would have to equal 42.25. So our hypotenuse would be the square root of 42.25, which you can do on a calculator to get 6.5. So we should, if it was right angled, our hypotenuse would have been 6.5, not 7. Finally then, our third one, if A is 3, that means A squared is 9. If B is 4, then B squared is 16. And if C is 5, then C squared is 25. And to test this out, a squared plus b squared, well, that is 9 plus 16. 9 plus 16 is 25, and that is the same as c squared that we calculated. Therefore, this is a right-angled triangle, and the right angle is opposite our hypotenuse. And we're done. So you can use Pythagoras theorem to tell whether a triangle is a right-angled triangle or not, and be able to see where the right angle would be in that triangle. Make sure you always put that right angle up. If it is a right angle triangle, make sure it's always opposite your hypotenuse or your longest length.